Hi students, this is Narayan Chandra Sinha and you are watching NCS Learning Planet. I know students, you all are at home and feeling boring due to 21 days lockdown amid COVID-19 pandemic. Now there is no study, no school, no tuition. But my suggestion is that don't waste your time. Better you can practice for your next class. Today, my educational video is for those students who will be promoted to class 10 and it is science subject. You know, I think you don't getting your books for of class 10, so I am discussing the first chapter of science book, which is chemistry chapter, and the name of the chapter is chemical reaction and equation. So let's begin it so that you can practice at home, and after that when you start full flash in study, then it will be more easier for you. Okay, let's start it. First of all, I think all know about the symbol formula. This is very essential for chemical reaction. By knowing the symbol formula, and then you are able to write reaction. So I am going to discuss symbol. Do you know symbol? Symbol is nothing but the short representation of an element by an alphabet. Suppose, what is the symbol of carbon? I will write C. And what will be the symbol of oxygen? I will write O. And when this together comes, then it becomes the formula of carbon dioxide. Okay, now what will be our topics? You have to know all the symbols and formula of few compounds. There are so many formulas, but we will discuss few compounds, and you have to know their name and formula. One have some commercial name, one have some chemical name. So you have to know the formula of some compounds like magnetic oxide, Fe3O4. It's the formula of magnetic oxide. And then methane, it is CH4. Then glucose, C6H12O6. And then sucrose or sugar, C12H22O11. Lead nitrate, PbNO3 Then acetylene, C2H2. Then methanol, CH3OH. Then quicklime, CaO, calcium oxide. And then slackline, CaOH2. Then limestone, CaCO3. Silver chloride, AgCl. Barium sulfate, BaSO4. And then copper sulfate, BaSO4, copper sulfate, CuSO4. SO2 is the formula of sulfur dioxide, and it has a suffocating smell of burning sulfur. Another is NO2 gas. It is a gas of brown colored. So you have to know their color formula like this. So let's finish about these topics. Now proceed to the main topics of the chapter known as chemical reaction and equation. It is a chapter which I am going to talk. So there is a word equation like this: when carbon reacts with oxygen, carbon dioxide is formed. This word equation can be represented by symbolically along with formula, and that becomes a skeletal chemical equation. So what was the word equation? Carbon reacts with oxygen gives carbon dioxide. So carbon is C, oxygen means oxygen gas, which is written as O2, and gives carbon dioxide means CO2. It is the chemical equation. So today our main topics is how a chemical equation can be balanced. So first of all, why we need to balance a chemical equation? So it is nothing but to obey the law of conservation of mass, which states that mass cannot be created or destroyed. The total mass before and after reaction always remain constant, and you all know this already in class 9. So what is the mass of carbon? Means it is nothing but its atomic mass. It is 12 gram. Oxygen 16 into 2, which is 32 gram. And what is the molecular mass of carbon dioxide? It is also 12 plus 16 into 2, 44 gram. So here you see the mass of CO2 44 gram, and the mass of carbon oxygen, when you add, it also becomes 44 gram. So the both side of the reaction, the total mass are same. In any reaction, the left hand side are known as reactant side, and the right hand side is known as product. So the total mass of reactant should be equal to the total mass of product. Now we have to balance this kind of chemical equation. So there are so many methods like heat and trial method, partial equation method, algebraic method, oxidation number method, ion electron method. So many methods are there, but which is very easy method among all these? I must say it is nothing but heat and trial method, or it is known as trial and error method, or traditional method, or also known as balancing by inspection. That is the basic method in the stage 10 standard stage. So let's start the balancing chemical equation. I am taking very easy example. This is iron when reacts with water, it gives ferric oxide and H2 gas. Now we have to balance this chemical equation. So first of all, the basic thing is you have to check which element present in any side in maximum number. Which element or which atom? Oh, okay. Before it, I am going to discuss one thing, which is for balancing equation. Suppose say NH3, you have to for balancing, you cannot write any number below an atom for balancing. Suppose like this 2 to balance nitrogen. You cannot write like this, or you cannot put any number within these two atom like this. It also you cannot write. So what you can write? You can write like this. If you were to put 2, then always put 2 before the formula like this. Again, suppose I am writing OH2. So how many oxygen? 2. Just multiply. How many hydrogen? Also 2. If you put 10 before OH2, then what is the number of oxygen? So it is very simple, always multiply. Here oxygen is 1, so you multiply 2 into 1, 2, and then into 10. So it is oxygen number 20. At the same time, hydrogen 2 here, and 10 into 2 also 20, like this. So just see, we go to this equation Fe3O4, we have to balance it. So first of all, oxygen is more in number among these elements, so you have to balance first oxygen in both sides. So here oxygen is 4, but in the left hand side oxygen is 1. So in order to balance it, it also have to be 4. So we cannot write below here, we have to write before water as 4. So it becomes oxygen 4 numbers. But see, at the same time, hydrogen, how many hydrogen it is? 8 hydrogen. So you have to balance hydrogen over here. So you have to put 4 also here, so that the hydrogen number becomes 8. Hydrogen 8, 4 to the 8. Oxygen 4, oxygen also 4. Now what is remaining? Iron, it is 3. So put 3 before Fe. You cannot write 3 here. Okay, just 3 before Fe, and see, it is perfectly balanced. Okay, take another example. Suppose this is ZNO, means zinc oxide, and then HCl. When reacts, it becomes zinc chloride, and then water. Here you can see also which element is present in maximum number. So obviously it is chlorine 2 or H2. The number is 2, here is maximum. So you can attempt either chlorine or hydrogen for balancing. So we are targeting chlorine. In the right hand side it is 2, but in the left hand side it is only 1. So in order to balance it, we have to put 2 before HCl. So chlorine is 2 balanced. At the same time, you can see hydrogen is also 2. Here hydrogen is also 2 balanced. Oxygen is 1, oxygen is 1 balanced. Zinc 1, zinc 1 balanced. So again, it is also easy equation. Now another equation, P plus O2, P2O5. You have to balance it. How? Very easy. Just see which number is maximum. 5. It is maximum. Here the oxygen is 2. Here is 5. So one number is odd, one number is even. You cannot make 5 over here. So what you will do? You just take the LCM of these two numbers. 5 and 2 means LCM means 10. So just put 5 before O2, it becomes 10, and then 2 over here, so that oxygen becomes 10. At the same time, phosphorus 2 to the 4, so you put 4 over here, and thus you can see the equation is perfectly balanced.